So this is the strange history of the internet. This is not an expensive or expansive history of the internet, but more my opinion on funny bits of internet history and also bits that might cause you problems in your day-to-day. So I'm Dax. I went to school at Allegheny College, political science, writing, and music, which is in Pennsylvania, the United States. I'm obviously not using any of that in my day job. So I live in DC now, and I work at KitCheck, which is an RFID pharmacy automation company. It's really cool work. We make sure that you don't have expired meds or recalled meds when you're at the hospital. I have 3 cats, 2 ball pythons, and a Brazilian rainbow boa, and if I make it to the end of this talk, you'll get to meet them. So let's hope I do. So I first got to say that the internet history starts a way long time ago and is on the shoulders of giants. So we had Ada Lovelace, who wrote the first computer program, and she did it without even having a computer. They weren't invented yet. Really incredible work. We had Hedy Lamarr. Most of you might know her as an early Hollywood star, but she also invented Wi-Fi. She invented it to be used on submarines during one of the world wars. The United States didn't go with her invention, but here we are 100 years later using it every day. You're probably using it now. We have Rear Admiral Grace Hopper, who coined the term debugging because there was a real bug in the machine, and she had to debug it in order to get it working. She also wrote COBOL, which is one of the early programming languages. We have Margaret Hamilton, who wrote code that ended up making sure that nobody died when we went to the moon. So she also coined the term software engineer, and she was part of a large team of mostly women who made sure that the automation and controls in the spaceships didn't break. People still can't find bugs in her code. They review it, and they no bugs. And then we have Lynn Conway, who we can thank for Google Chrome taking up all of your memory on your keyboard, or not keyboard, your laptop. In the 60s, she worked with IBM and invented out-of-order execution, which is used by most modern computer processors right now to improve performance. So 1966, we get ARPANET, which is the Advanced Research Projects Agency Network. Up until this point, most communications were done with circuit switching, as exemplified in the traditional telephone network. So you had 2 endpoints, and they circuit switched and talked to each other. You couldn't really do like 3-way calling or any of that jazz until ARPANET decided to look into packet switching. And it implemented the first packet switching network, which was the TCP/IP protocol. Before, if you wanted to talk via computers, you kind of had to have a computer for each person you wanted to talk to. So if you were in a research lab in Washington, D.C. and wanted to talk to somebody in Malmö, you had to go up to your computer, which is labeled Malmö, and then talk to them. And then you wanted to talk to somebody in Stockholm, and you had to go over to this one, which is labeled Stockholm. But now you could have a single computer and still talk to all of these different places. So in the 1970s, we got the Network Information Center. This was the place that handled the domain name system, and it allocated domain names to IP addresses and cataloged all of this in a big, huge text file called host.txt. That file was handled by Elizabeth, also known as Jake Feinler. She ran the NIC at Stanford Research Institute. To get a domain name from her in the old days, you'd have to call her up and go, "Hey, Elizabeth, I want this domain name." And she'd be like, "Okay," and then kind of give you a number and put it in the host.txt and made it so. She did not work on weekends. She did not work after 5 p.m., and she did not work holidays. And she also didn't have voicemail. So you had to hope that you called her at the right time in order to get that. She also had kind of like this internet white pages and managed all of the RFCs around NIC and ARPANET at the time. So if there's a RFC that you're reading from the 70s and 80s, her name's probably on it. So this was from one of the early RFCs about how to get in contact with her. They had some like weird domain names back then, like sri/nick.arpa. And at the time, this was the extent of the documentation around domain names. Provide a mechanism for naming resources in such a way that names are usable in different hosts, networks, protocol families, internets, and other administrative organizations. At the time, there were 6 major ones: .com for companies and businesses, .edu for schools or other educational institutions, .gov, which was for government agencies, .mil, which is for the military, which the military funded a lot of this, so they had to get their own. .net, which was for various network-type organizations, so any other organizations that were dealing with the internet could use the .net. And .org, which was kind of this catch-all. You don't belong in the other ones, but you are an organization that works on the internet. So if you weren't involved in the making of the internet, you couldn't really get a top-level domain. And Ms. Feinler would make sure that you actually had the correct credentials to buy that domain, which meant that if she were still in charge today, I cannot have dax.cat. I use this as a collection of photographs about my cat, but the .cat top-level domain is actually for the Catalonia region of Spain. So she would have denied me. Luckily, Hover exists now, and I was able to get it, as well as Google Domains, Namecheap, GoDaddy, a lot of other businesses that are now involved in the purchasing, trading, and assigning of domain names. In 1972, and they were responsible for assigning the IP numbers. They had Joyce K. Reynolds, who oversaw a lot of IANA. She was the one in charge of putting together the RFCs. She was the one in charge of kind of making sure that the internet was documented. Documentation, a problem even back then. So most of the protocols that you use today, Telnet, FTP, POP, she wrote the original specs for them. So IANA was established kind of to oversee a lot of ARPANET and also a lot of other of this. There was many internets back in the day, not just ARPANET, and IANA was the one that was kind of overarching, making sure they all talk to each other. And part of this also involved socket numbers. So when you start up a like your local host, it's using a socket number, and those are all over the place. And IANA kind of makes sure that those work too. This becomes important later on. So I alluded to this already, but in '82 we got email, a simple transfer protocol. And I did a little digging into what exactly an email address could be. You have username at hostname.top-level-domain. If Sailor Venus had an internet and an email address, I know she's from like the 90s, but this would probably be what it would be. And a lot of people recognize that as an email address. Simple mail transfer protocol also says that only the local part can be interpreted by the host. So you set up an email server, you get to decide what characters people can and cannot use. So if you decide to make your own email, you could say that your host is not going to accept the letter A. So people won't be able to make emails with the letter A. But you could say that they can use another @ sign. You could say that they can use a space. It can start with a space. It can have spaces, equal signs, @ signs, and no A's. This, like I said before, makes validating emails really hard because you will probably get a lot of people using Gmail, which already has its list of characters you can't use, which spaces you can't use, @ signs you can't use. But you're going to have that one cowboy like me that decides to set up their own email host and completely throw off all of your email validations. So I talked about this a little bit earlier, but hostname. The goal of domain names is to provide a mechanism for naming resources in such a way that the names are usable in different hosts, networks, protocols, families, internets, and administrative organizations. This is about the extent of documentation on what a domain name can and cannot be, which means all of those things I just told you about email localhost parts, as long as you're within a certain level of bits, you can use domain names that have spaces if you want them, but you have to kind of set up your own thing for that, because a lot of hosting companies won't let you do that. I tried to buy one with a space in it, but Hover wouldn't let me. But if you want to roll your own internet, you can, and still be compliant. So eventually, Elizabeth Feindler was like, I can't do this anymore. My host.txt is larger than my computer can handle right now, and I'm getting flooded with calls. So they decided to come up with RFC 883 and 882, which sought an automated naming system. This is how we get to, this is the next step towards having the GoDaddies and the Google domains. So they kind of had this, you don't have to read all of this. This is just an excerpt. But they kind of had this problem of scale where Elizabeth Feindler was only one person, and they had a lot of other people that wanted it. So they started setting up this automated system where you could request a domain, and as long as the port was there and your domain was there, you could get it. So Elizabeth got to get her weekends back. So when they set this up, they set up IPv4, which is outlined in RFC 791. It's a connectionless protocol for packet switching between networks. It operates on this best effort delivery model, so it'll try to get you there. It can't guarantee that it will get you there. So if you type in google.com and there is something wrong with Google servers and you can't get there, IPv4 won't tell you that there's a problem with that. Web browsers will. They'll figure that out. But the actual IPv4 protocol, it'll make an attempt to get there, but it doesn't guarantee that it will get you there. There's the transmission control protocol over top of that, which assists. So when they did that, they set up classes of internet IP addresses. So you have classes A, B, and C, which are networks of 3 different network sizes, and they're unicast addresses. Class D is multicast, and Class E is reserved for future use or experimental purposes. So this was introduced in '93, and they thought this would be great. That, okay, the internet's not big, it's not going to get big. We've already addressed the scale issue. We got something automated for Ms. Feindler. We're never going to run out of IP addresses. That's never going to happen. We did. So we set up classless interdomain routing and variable length subnet mapping in RFC 950. So classless interdomain routing is based on this concept of variable length subnet masking, which allows a network to be divided up into various subnets. And it's kind of like EC2 instances if you use Amazon, where it kind of scales to what you need. This is what that was supposed to be setting up with IPv6. So IPv4, you've got, that's a usual IP address. And then IPv6 is, it looks like weird, but it's creating that variable amount of network available. So what happened was C was the smallest size of IP addresses, and most websites required a little bit more than C provided, so they would get bumped up to B. But B was huge, so you had my tiny little fan site for The Last Unicorn on a Class B domain. So this made Class B exhausted incredibly quickly, and so then even smaller sites ended up having to get Class A. And that's how we ran out of IP addresses. The solution could have been, let's open up Class E. We've got all these ones available that we could use for future use or experimental purposes. And isn't this the future, where we have no IP addresses? But we decided to go with IPv6, and only about 10% of the internet is on it so far. So a lot of places haven't really been, a lot of networks have not been switched to IPv6. And it's kind of a problem of being able to backport. So when they came up with IPv4, they had to make sure that it worked with existing, already there, domain names matched up to an IP network. And and also have the scale for what they saw is this really tiny internet. Hopefully we don't run out of IPv6 ones, but we're headed there. So I have one more funny little thing that might make your life frustrating. 96, we got the Hypertext Transfer Protocol, version 1. If you've never bashed your head against this little part of the HTTP protocol, congratulations. You haven't lost 2 weeks to this. And if you haven't yet, congratulations, you're not going to. Refer. The refer request header field allows a client to specify for the server's benefit the address or URI of the resource from which the request URI was obtained. This allows the server to generate lists of backlinks to resources for interest, logging, optimized caching, etc. It allows obsolete or mistyped links to be traced for maintenance. The refer field might not be sent if the request URI was obtained from a source that does not have its own URI, such as input from the user keyboard. If you're making HTTP requests in something like Postman or another graphical user interface where you have to fill out all the headers, you might have sat there wondering why this isn't working, because you type refer, which is spelled R-E-F-E-R-R-E. Isn't that how you spell refer? It is. It's misspelled in the documentation, and it was misspelled in being pushed out to the world. So what happened was these two guys, Philip Hallman Baker and Roy Fielding, were writing up the documentation for this and also implemented it at the same time because they were efficient. And they typed refer into their text editor, and it said it was misspelled. So they typed it in a different way, and it said it was misspelled. They typed it in a third way, and it was still misspelled. The Unix spell checker that they were using at the time did not think that refer in any possible spelling was a word. So they guessed at which was the right spelling rather than getting a dictionary or asking someone with an English degree. So from now until all of eternity, refer in your HTTP headers is going to be misspelled. And hopefully you will not be like me and lose 2 weeks of progress to that. So we got to the end of my presentation, so you get to meet my cats and my snakes. The great big furry one that is gray, that's Tom Waits, followed by Dai, destroyer of all things good and pure, Stormageddon, Dark Lord of all. In the corner down here we have Melusina, the ball python, and her new little sister, Luna, the ball python. And lastly we have Calcifer, the Brazilian rainbow boa. I'll be out there drinking coffee. Come talk to me if you want to know more about how weird the internet is. Thank you so much for your time.